So good morning all. Good morning. Okay. So we have already completed 3 days FDP program successfully, and today is the 4th day. And first session we have with us Professor Kumar K. Sir. He is there with IIT Hyderabad from last more than 10 years. Okay, he visited many times Gulbarga, PDA college and our institute. Earlier, our institute, School of Engineering, was under the mentorship of IIT Hyderabad, Department of Electrical Engineering. Kumar sir did his PhD from Indian Institute of Science, and then he worked as a design engineer in American Power Conversion Limited. Then he started his journey as assistant professor in IIT Hyderabad, and today he is professor, and he has completed many projects awarded by SERB and other agencies, and he has already many publications in IEEE, industrial applications and power electronics, all transactions and good journal publications he has. He has already done a lot of contributions in the area of multi-level inverters, open and winding induction motor drives, electrical drives, microgrid application, operation and control. Okay, so he is a well-known and a dignified personality in the electrical engineering domain and very down-to-earth personality. I request all the participants to make use of it, have a good interaction. You will get clearly the picture how the research is going on in the power electronics applications domain. Definitely it is helpful to interact with Professor Kumar sir. With this brief introduction, I request Kumar sir to come to the dais. Please, sir. Yes, sir. Yes. Amrendra sir, HOD Amrendra sir. Yes, sir, please, sir. No, sir. So I request Professor Amrendra to welcome Professor Kumar sir with a small bouquet, a token of love and appreciation. So now I request Kumar sir to start the session. Okay, sir. Sheetal, sir, adjustment. Yeah, HDMI is also fine. Bigger cable. Will it come there? No, I don't think so. No, that's okay. I think I'll keep it here. No, don't worry. I'll keep it here. Yeah, sure. I may be writing also. Yeah. So good morning. Yeah, sorry for the late. Because of traffic and other things, like we've been started early. I hope I'm audible. Okay. You please feel free to disturb me anytime. So when sir has called me for this AML, I felt that I'm not working AML. But today I may not be talking on AML, which directly going to be, but I feel that
Because when I looked at several things, because I'm also a researcher, I also had to cope up the things. No, majority of AIML, if I can see that, maybe I may be wrong, because my inputs, whatever my assumptions, and I'm not going to deliver whatever I consumed. Maybe some of the things I could not have been consumed the information which is available in the internet. When I look at it, this AI and ML is more of coming on autonomous vehicles. How do you make it? Or something like optimization of routes, or some kind of optimization of something else, like no, on the controls perspective and all of them. But if I can retrospect on the other side, the baseline of electric vehicles, if I can say that, powertrains. So not much of AI ML has gone into it. You can ask me saying that what I should look at it. There is a motor, there is an inverter, there is battery. What should I look at it? For a certain extent, at the battery level, something has happened to estimate the SOC using AI ML, or life cycles of the batteries, or identification of the faults, charging stations, optimal charging locations, optimal charging sites. You can counter argue with me, like, because I'm not a master in it, so you can always counter back and saying that, like, if whatever you have it. But when it comes to a kind of electric vehicles, not much of AIML went on the drives and power electronics. You may ask me saying that why should I do it? Drives is what? It's a kind of 6 switches were sitting there, and there's a controller. I can turn on and motor will rotate. What should I do it? Like, no, I'll try to make it as informal as possible. That's fine, no? Yeah. So just for the sake of understanding, let's take about why we went for a 3-phase system. The 3-phase system we went majorly 2-3 reasons. One of them I'll try to put it. There are several things, because my own beliefs only I can place it here. So one of the major reason is that I want to have a rotating magnetic field, because the motors has to rotate. So that means to say that one physical parameter has to move. To move the physical parameter, there should be an imaginary parameter which is rotating. So we made the stator magnetic field, which is the imaginary field which has been rotating. The poles have been rotating, and there is a physical field was been following it. And of course, you can give him induction machine saying that, sir, both are imaginary and they are rotating it. But eventually, they are following one to one. So to establish a rotating magnetic field, it is not possible with single phase. 2-phase is possible, but there is a asymmetric, like, no, 90 degrees phase shift has to come. Then the symmetrical rotating magnetic field with easiest thing which was possible is 3-phase. And on top of it, the 3-phase has been derived into a power system. When you want to transfer a power for longer distance, instead of having a 3 single phases and 3 2 wires of 6 cables, it becomes 3 cables. Either if you do a delta and star, that has been added advantage for us. Once the system has evolved, now my power system is 3-phase system. If I want to do something here in my house, I cannot dream anything other than 3-phase. If I want to have some kind of thing, I have to be a 3-phase. Is it right? And we have been habituated going on 3-phase, 3-phase, 3-phase for longer times. Now I'll come back to a counterpart. If I have an inverters. In inverter, before going to inverters, let me ask you this. So now I want to change the entire system into 3-phase to 6-phase, 5-phase. What should I do? It has to start from generating stations. The generator has to change from 3-phase to 5-phase. That means inside the generator, instead of 3 windings, I have to place 5 windings, and from there I have to come with a transformer. The transformer has to be 5-phase, and then the transmission, distribution, and the distribution again, like, no, you have to be balanced. Now 3-phase is, we have somehow balanced one pole to the other pole, another pole, but 5-phase balancing mechanism is established. Everything is going to be very complicated. You cannot change it, because if I want a 5-phase motor to run at my home, instead what they do, in olden days, they used to have a phase changing transformers, like, no, you can have a transformers, something like more popular, we don't pay much of attention, we put that into the back bench, is CUK connection. Just playing with a matrix, not matrix, vectors. So similarly, you can do 3-phase to 5-phase and all of them, you can get around. But when it comes to power electronics, what is a phase? If I have one leg, that means 2 switches, single phase, 4 switches, 2-phase. So the number of legs increases, the number of phases increases. So then that case, why should I refine myself into 3-phase systems in electric vehicles? Why can't I go for a multi-phases? You can ask me, sir, why should I go for a multi-phases? Why can't I go with only 3-phase systems? The 3-phase systems, the disadvantage or advantage, whatever you want to say, assume that I will give you 2-3 examples. You can derive as many as possible if you are interested. Let me ask you a question, like no, just to synchronize my vocabulary with your ears, I will ask you 1 or 2 questions at least. Now, in 3-phase, have you ever looked at space harmonics? Space harmonics. We always look at time harmonics, which is generated by the square pulses or any kind of train of pulses. We do the FFT and all of them. That is a time harmonics. There is a space harmonics. What is this space harmonics? The winding in a machine has to be distributed like a sine wave. That we don't do, no. We do it like a 3-phase. This is a consolidated waveform. Like no, we give certain slots for this, certain slots for this, certain slots for that. It's not a proper distribution of sine waves. I don't know who have done mission modeling, they will understand, like no, the current into the number of windings has to, the MMF has to be sine wave distribution, which will not be there. There's some kind of staircase waveform will be there, MMF distribution. If you have that staircase distribution, your voltage EMF induced or a kind of back EMF induced or whatever you want to call, that also will not be pure sine wave. Because MMF has to be sine wave, no. If MMF is not sine wave, it's something like this. As a faculty, we don't know, how student will come to know. Don't tell me that A is there, sir, NPTL. That is a different story. But what I am trying to say that MMF itself is polluting because of the slots and the concentrated winding. It may be distributed, but it's not properly distributed. You can go back and think about it. So why does it happening? Because 3 phases, 120 degrees has to be consolidated for each phase. When number of phases goes up, the space comes down. So then what will happen? The distribution is going to be more uniform. So thereby space harmonics will come down in the MMF. That also results into voltage. And of course, some of you could have been, or we could have been realized that the induced output voltage is a kind of triangle, like no, the staircase waveform, and that inductance and all of them will take away. Now my question here is that, if that is the case, why can't we go for a multi-phase? This is the trend. So because I am designing new motor for electric vehicle, and I am designing new battery backup, and I am designing my own inverter, then why should I go with the age-old 3-phase systems? I can go with that. You can ask me, what is another advantage of it? Why should I go for it? It is very simple. I will just go back at transformer principle. Is it right? Is my voice is clear? I am speaking nonsense because I am not moving slides. I want to give some brief before going that, because I am not smart to give AML, that algorithms and all of them. I don't have it. I am trying to give a preamble before going back to this thing. Okay. You can interrupt me anytime, please. Where I am? Somewhere. Transformer. So something like, you have a 3-phase systems. Assume that the number of conductors in the slots are constant, because you cannot accommodate more, no? Because the power depends on the number of conductors and the current which is going through it. That MMF decides. Whether it is coming from A phase, B phase, C phase, it doesn't care. Like, no, the current was going in one direction, current was going in another direction. If it is going in this direction, the flux distribution will be like this, one pole. If current is coming in this direction, the flux distribution in another direction. This is another pole and this is another pole. And number of directions you change it. If you have 4 pole, the conductors, one set of conductors are carrying current in this direction, other set will be like this, another set like this, another set like this. That means this is a 4 pole. This is all what we are going to do it. No magic, nothing. So now if I want to increase the poles, what has happened? I have to play with the number of currents it has to go. Those current directions, magnitudes can be different, but the direction of the current is very important, and that I can do with 3 phase, 5 phase, 9 phase, 15 phase or 20 phase, it doesn't matter. Like, no, the currents has to be uniform. Now if I have more kind of phases, I am going to reduce less space harmonics, which is going to be very advantage when you are going for higher level. One of my friend was telling that he was working on a transformer efficiency increment. He said that, what is there in the increment in the transformer? Transformer is giving above 99%. Why are you worried about it? It is something like no, I have seen some of the parents were shouting as kids, saying that although you got 98, oh, you left 2 marks, you have to. some of your parents, saying that like, I still remember one of my friend, like, I got everything around 65, 70 marks, and I was been like, throwing my books and running, jumping, and all of them going to home. Where my friend has 95, 96 marks, he was still crying there at the school. I said that, why are you crying? No, his neighbor got 1 mark above him. It is not that he got 96 or something, like, no. Because their parents are saying that I'm paying the same fee, I'm giving the same kind of comfort what that guy is getting, why you have got 1 mark less? It is something like that. I looked at him and saying the transformer, that is only the example I could able to remember, boss. You are getting 99 and above, where we traveled all the way from kind of electromechanical, which is 35%, maybe that is the derivative point for the pass mark. 35% to 99% you travel and still you are working. And he says that, no, Shiva, this something, if I can crack that problem, my entire life is set. And says that, what is the power level? He's saying that hundreds of megawatt to gigawatt level. Just think about a gigawatt level, increasing 0.1% efficiency, 0.1 times of just take 100 megawatt is what? 1 megawatt of power, and per day 24 megawatt hour, and think of year, and that runs definitely 50 to 100 years. Just think about how much of power is going to save it. That means to say that that efficiency conscious has gone up when the power is increasing and increasing. And today we think about the efficiency plays a matter. The reason why I am saying is that we think an electric vehicle, what is the power of the motor which you are going to place now? 50 to 70, that is something like low end vehicles. Mid end vehicles for more than 100 plus. And sports vehicle, if you go that category, it is going to be there. 100 kilowatt, and you increase the efficiency by 1-2%, the run time you can increase it. Is it not? So that means space harmonics is very important to maintain the efficiency and all of them. On top of it, I'll come back to the other issues which you have to look up. The second issue is that if I go with only 3-phase system, if one of the winding fails, what will happen? Maximum we can run it as open delta. This is what we teach in open delta. What we said, the output power can be around 57% something. You correct me if I'm wrong, because around 56% or 57% was there. Like, no, here 1% here and there has been going away, because I'm not writing exam, so I didn't remember the numbers exactly. So 56-7%, that's okay, power is fine. But what is the initial torque which it can offer? It is something like this. You have a bank balance of 1 crore, but you don't have signing power. Banks have been frozen. What to do? Nothing can be done, no? So it can give a power close to 56% of the rated, but what is the starting torque? Absolutely zero. Not absolutely zero, close to zero. What I can say that, like, no, very close to a kind of, that means to say that you cannot compare with the full torque to a kind of starting torque in healthy condition to open delta. Now, if it comes to a kind of electric vehicle, in a fault conditions, what I can compromise? Torque or speed? Speed I can compromise, torque I cannot do it. That's what some of the movies they say, no, if you want to dig a water for 100 meters, you dig only 99 meters and leave it. So you know that if I want to move this, what is the force I required? Just 0.1 Newton meter lesser than that force you leave it, it will not move. Rest of the life it will be like that, and you are going to consume the entire energy which is going to be there. That means torque is very important, otherwise it cannot even move. So you cannot compromise torque. When it comes to fault conditions, your torque itself is dramatically coming down. You have a power, everything, but you don't have a torque, your vehicle will never move. So instead of 3 phase, if you go for higher phases, you get a better fault tolerance, better efficiency and better fault tolerance. On top of it, I will tell you one more thing. This acoustics. People are very sensitive with the noise. Now itself people are complaining if the two-wheeler goes some kind of noise. When IC engine is there, nobody has any complaint. When IC engine is sitting in the front side the car, Your AC noise was not visible, tire noise was not visible, nothing is visible, no, you could able to hear anything. But once IC engine gone away, this is something like, in the class one person will be there to make the entire noise, then everybody will be good boys except that guy. If that guy goes out, then a lot of issues will come out. Now this noise is also going to be a kind of huge thing. And this acoustics, why I am saying is that when the space harmonics comes down, you just think about a flux distribution and the distributions in the core, like whenever you want to do it, that is also going to be have most impact on the acoustics. With all those things, people are going for a multi-phase systems. When I want to go for a multi-phase systems, how do I handle the complications on top of it? I cannot go with a very conventional way which has taken for 100 years to evolve, all control methods for 3-phase and all of them. So can I think something differently? Can AI can be brought into that? That's what my philosophy. I am not going to show anything which AI model you do like this, you are going to get this output. You apply this. This is the data available in this bank, and this is the algorithm you apply, and this is the output. I don't have anything. I'm trying to show the problems which we are thinking, where if not the advanced AIs, at least some kind of analysis has to be figured out. That is what I'm going to do it. This is a preamble. Any questions on it? Most welcome. No? Yeah. If not, I says that why complications will increase. I'll tell you. It is very simple. Like, no, when our salary is only a kind of 1,000 rupees, we will only look at the bread and butter. Like, no, nothing else. Like, no, only rice. And once it becomes 1,000 to 10,000, no, then EMIs will come into picture. That EMIs all the way from personal loan to car loan to home loan to education loan, all of them, like, then the complications, the brain is going to be exhausted. Similar way, when 3-phase, everything is simple. When the number of phases increases, we will not stop there. We are going to go for multi-level, multi-phase, the distribution of the energy, batteries and all of them. Then what will happen? The complexity of the system will go up, and where the conventional things may not be worked out. That's what, at least we are working on conventional, but at least there is scope for it. Now, if I can say that, because anyhow you have gone through for 2-3 days, I am not going to stress much on electric vehicles. Definitely they are redefining modern mobility. And only thing is that electric vehicles, on top of it, whatever autonomous, the data driven and that and all of them, they are mainly heavy on power electronics and control strategies. Without these two things, you can do anything superficial, which is going to be a kind of what I can say, without heart you are running around. Like, no, this, I feel that this is very, very important. I think here very less AI and ML went on. Some of the problems where we think about it in this strategy, I'll do it. Just to understand where I can put our thing, like, no, I'm not going out of that. This is like introspective, like, no, inside to look at it, what we can do it. The first thing is that energy sources, yes, at the battery packs, we can do something. There are a lot of AML went on it. The estimation of SOCs, estimation of the charge left out, the distance can be traveled, estimation of remaining life, the what you call that battery life, and all of them, the charging stations optimizations, like, no, you name it, many things have happened at battery level. So I'm not going to talk on it. That's the reason I have made it a color. Now it comes to power electronics. This power electronics, now there is a DC to DC converters can be there for chargers, or AC to DC can be there, or whatever universal chargers they call. Input that can be AC, input can be DC, or input can be battery, input can be PV or anything, like, no, which comes into picture. There also you have to have some kind of control strategy to handle what you can say that, like, no, very simple. Just now I've been talking to another talk just half an hour back while coming another minute. It says that previously at least people thought that charging is disciplined, discharging is indisciplined. Why? Discharging time you are driving. It depends on the person who is driving can decide the discharge patterns. But charging I have a control. But charging also become indisciplined now. Because if grid is available, you have to charge it faster. If battery is there, you have to charge it faster, and all of them, like, no, that also went on. Like, how do you handle that? That's one thing. And this also can be interact with onboard charger. Without onboard charger also you can be there. So that means to say that if I want to integrate all of them, it doesn't require intelligence. It should be able to sense the limitations of the input. It should be able to limit the look at the batteries. When after all, your mobile batteries has an intelligence. I don't know, at least who worked that what I can say, Nokia 1100 kind of thing. Every one of maybe some youngsters like Gen Z I could able to see. Other than that, I think most of us could have been seen that. How many of terminals you have seen those batteries? 3, no? Why 3? 2 is sufficient, no? Plus and minus is charging. You look at any other battery, it only 2. Why 3? The third terminal will indicate the health of the battery, the temperature, and that is the third one decides what fast it has to be charged, what has to be charged. And of course, now batteries we cannot see it because they seal it. So that means to say that you have limitations from the battery, you have limitations from the source, and you have limitations on the power electronics itself. Within that, there also I think a lot of intelligence can go into picture. Okay. The other thing is that the inverter, this inverters like no, I can say that the power converters at the inverter side, now typically we may think that inverters only 2 level, but it can go for multi level and can go for multi phase also. When it becomes multi-pole and multi-phase, the complications are going to be increased. There one of the professor told me saying that you have something, even I have been working for almost more than 8 to 10 years on that, I could not able to crack it. The thing what he said that, you know, K-map now in digital circuits, 1 and 0, we optimize the circuits. In the inverter is also what, each leg is 1 and 0 only. Previously it is only 3 phases, 3 legs, 3 1 zeros, that is 8 combinations, we call space vector and all of them we do it. When number of phases increases, number of levels increases, you just think about how many combinations will turn up. Can we not optimize that? When we can able to optimize the digital circuits, can we not optimize the circuits? To get the same amount of thing, multi-level and multi-phase, just think that if 3 phase becomes 5 phase, how many combinations will come? If it is 3 phase, 2 power 3, 5 phases, 2 power 5. If 3 phase becomes 3 power 5 or 3 power 3, 27 combinations, 5 phase, 3 power 5, it will become 9 phase, 9 level, then becomes 9 power 9, those many combinations. Can we not optimize? Can we redefine something like K-map for power electronics? So what I am trying to show that this is a humongous data, lot of combinations. You can ask me, sir, what is the advantage of it? The advantage of that is very simple. Now we know that 2 phase means 3 phase, 2 level means 6 switches. If it is NPC, 12 switches, it increases, like no, each level will increase 2 switches. So instead of that, can I go in a differently, like no, optimize that? I'll come back to that one of the example, like what can be done, like no. So that is also another area, and few things I'll extend, few things I may not be doing it. And when it comes to motor, the motor, what kind of motor we have to take? Is it induction motor, PMSM? Initially they says that induction motor, then slowly they said that no, PMSM. Induction motor because Tesla took it, then it became PMSM because more weight per torque ratios. Now because some other country is trying to control on the permanent magnets, they are pushing for again magnetless things, and all top of it all kind of motors are coming into picture. So how do you do that? Especially in the fault, how can I do it? And the transmissions, definitely previously it's only kind of one transmission and like that. Now you have 4 motors on 4 wheels. How do you control the speeds? Even 1 RPM in speed, your efficiencies will be deteriorated like anything, because 3 vehicles drives at 1 speed and 1 drives at higher speeds, then vehicle will not go on straight, it will definitely take turn. So the synchronization is also going to be huge. So this is what I can be able to say, that integration of all these systems very important to get an efficiency. It is not that easy task. So given said that, what should I do? I have been focused on failure things. Failure things can be done in several ways. One of them thing is that you predict it before it's going to be failure. How do you predict it? You can predict it based on the current signatures of your battery. current signatures of the motor and gate driver signatures of the inverters or gate to emitter voltages. You just think about whatever the parameters we can take about, and the thing goes on in life. So what I can say that, like I can say that the battery failures, I'm just focusing on few things. Battery failures and power electronic converters can be failed. That failure can be switch open circuit or switch short circuit. Beyond that, it is as simple as us power electronics. Just either on or off. It will never go into linear zones. We always believe that either this person is good or bad. That's it. No, if it is good, means good for all the time. Sorry, I don't know. So, electric motors, here the winding open circuit faults and winding interturn short circuit faults also can happen for longer times, like no, because when you are designing an electric vehicle, you are expected to have something like 15 to 20 years. Okay, so in that time, the failure typically happens because of what? Insulation failures, like no, that insulation failure can cause for interturn short circuit, or open circuit faults if conductor melts, if you don't properly taken care of it. So, now identifying faults is one thing which we can think about historical data, the current signatures, how they are changing, the battery charging time and discharging time, temperature rising curves, and all of them can be taken. AML has been extensively used on the charging of the batteries and estimation of the life and all of them, but I have not seen on the drives perspective the current based on the current signatures or some other signatures to do it. At least in my place, some faculty who have been worked on current signatures to estimate the battery, the life of the vehicle and all of them. There are some work has been done that also can be taken up, but we cannot able to take the entire thing. I am trying to give the glimpse, and here saying that one thing is identification. Okay, you failed to identify, everything is done. During the fault, what should we aspire and design? Okay, some fault has happened. One thing is that you get the data and estimate that okay, next 5 years, 10 years will happen something. If not that, if something fail happen, in that instant, what should I do it? Possibilities to compromise. What are the things I have to compromise? Like just now I said that if some failure has happened, what can I compromise? Speed can be compromised, not the torque. Is it right? Similarly, what else I can compromise? That compromise depends on, requires some kind of intelligence. So you can easily say that, like okay, I can compromise on AC, I can compromise on some kind of music systems, I can compromise on power steering, maybe I have to push it, but I may not be able to compromise on power brake because your leg has been habituated for something. So there are several systems. How do you integrate it? How do you assess that fault? Something like ABS is there. ABS, how it works? Like no, it is not with one system. It goes with several systems which has to be. Even like no airbag. Airbag is not with one system which is going to happen with the collapse. It depends on the previous speed, present speed, what speed it has been stopped, what is the impact has happened in front. There are a lot of data comes into it. So here also when fault happen, you cannot think that do you want to leave the driver intelligence to decide what has to be compromised, what not to be compromised. So how do you integrate it? Like no, what I'm trying to say that I'm trying to bridge the two gaps between the core versus that side. Okay, so how do you decide that? Or what I can say that like no, there are some vehicles goes with some kind of friction mode kind of thing, like no, which consumes more energy and all of them, like no, how do you avoid it? Sometimes can you limit the gear to fifth gear? You don't allow him to go to fifth gear, even you try to push it. Is it doesn't make sense? Just allow it to third gear only, because if it goes to the fifth gear, you may be the reason is that your drive cannot go to higher speeds and you push your gear mechanism to higher gear, then what will happen? Your actual speeds will come down. When it comes down, you just think about the efficiency curve of your drive. When it comes to lower speeds, what will happen to your efficiency? Less. The driver may not be knowing it because he is habituated to drive at fifth gear. So what are the things has to be limited in the fault condition? Not only taking care of it, there are a lot of peripheral things has to be taken care of it. Okay, so for that, what data I should able to collect it? You ask me, sir, what are the things? I'm also working. If you could able to capture that gold mine early, you publish it. Otherwise, I'll also publish it at some point of time. Okay. So we should have a clarity and possibilities to compromise based on the fault. It is not a single solution. You have to assess the fault severity. You have to assess the longevity of the fault. That means how long it can hold. Because if something happened, something like I'll tell you, the most serious thing, not many people care for it, is interturn. Assume that you have a transformer. I have windings like this. Assume that these two conductors got short circuited. These winding turns may be small, but what has happened? Previously it was one winding on the secondary. Once these two got short circuited, the middle two turns got short circuited. Now it became a two windings. Just imagine, like, no, there is one winding, there is another winding in between short circuited. Now what has happened? One winding at the secondary short circuited, another winding is open circuited. Now whatever the voltage has to come to the secondary, the short circuited winding has to carry huge current such that volt per turn is equal to I into resistance of the circuit or impedance, whatever you want to call it as. That much of current has to go. Where is that current is coming? From the primary. So you should be able to assess how many turns it could have been happened, because you cannot ask. It says that I started, the current will be huge in the interturn shorts, but it will not work. Like, you cannot ask in the middle of the jungle, if something has happened, you cannot say that the battery is going to die. It says that even die tomorrow, I will buy new battery, but I have to escape from this place. So you have to assess what is the kind of, what time it has to be turned on, what time it has to be turned off. There has to be cooling mechanisms and all of them to be established. And also I want to say that all these compromises you have to take care of at the time of design itself. I'll give one or two examples. So something like one of my teacher or one of my friend told me this. We have kidneys, no, that has been designed 4 times than what we required. That means we can survive with half of the kidney, although we have 2 kidneys. That is the reason they could able to donate one and they could able to survive. That means what? 4 times. That is the reason once. Assume that if it has not been designed like liver, like, no, I'm sorry, why I'm getting that liver, this means today my friend is going with a liver transplantation. My colleague, like, no, not. So you cannot sacrifice that, no. What I'm trying to say that, I'm not laughing, but this, yeah. So what I'm trying to say that there are something you have flexibility that you have been ready to overload it. Some of them are not ready to do it. You have to design for something. I assume that if it is a towing vehicle, in towing vehicle versus regular vehicle, what will be the difference? In towing vehicle, it can take more torque. Maybe the speeds will be lesser. So it has been pre-decided. You cannot ask your Maruti 800 to be a towing vehicle. Is it right? So that means you have to ahead of that thing, and you cannot ask that, like, no, somebody says that, like, no, I want to have a Ambani kind of security because I have 1 lakh in my pocket. Is it possible? So what I am trying to say that you have to assess what is the thing which is required, what is not required. That has to happen at design aspect also. That is also going to be very interesting problem. You have to take a lot of case studies and try to do that. What has to be overloaded, what has to be something. I'll tell you, very simple, easy to visualize for us. The conductors typically take 50 to 60% overload, or even sometimes 100% overload for shorter periods. Same time capacitor can take? No. If capacitors can take, then what will happen? Like just now they are giving compliment, I've been put on weight. The capacitor also becomes, you know what I can say, bulky thing. You cannot use it again. Like, no, it is something like conductors, it will go back the temperature and again you can use it, even you use 200% for some time. But capacitors, once you use, no, you have to replace it. That means to say that every design aspect, every place, you can give a thought that what has to be overloaded in my fault condition. That's very, very important. You can do it. And as a case study, I have taken induction motor because I am familiar with that. Okay. Just before going that, I'll introduce a simple drive kind of thing. What is there? We know this is a popular thing because this is not there in the EV, but this is very popular thing, so I have placed it. Okay, the popular thing is that you have a 3-phase supply and this is something like your inverter and this motor, and you have the control speed reference and PWM. If it electric vehicle, what will happen? This AC to DC will not be there, you may be having a DC to DC, here it is a battery, and here what will happen, there will not be speed reference and voltage, you have something like a direct torque control or vector control or hysteresis control or some other closed control to get better performances. Is it right? Now I said that the faults can happen here and here. Now just say that 2-level inverter fault has happened. How to handle it? Handling of faults in 3-phase systems. So what will happen in 3-phase systems? My handwriting is very poor. Okay. If I take this 3-phase system, assume that one of the switch got failed. It can be open circuit or short circuit, just one of them it got short circuit. Then how to run the system? Typically we have to forgo that and only 2 phases will run, that goes into open delta, which will not work. So instead of that, we should know what we required. I know majority of may be knowing it, but at least the Gen Z generation you don't know, at least for them it may be helpful. So when I have a load like this star connected or delta connected, whatever, I am not biased with the star, either delta or anything, what should I want to have it? Phase voltage has to be balanced or line voltage has to be balanced? Phase voltage has to be balanced. Line voltages? They also balanced. Then pole voltages? Pole voltage has to be balanced. Confusing? All of them are one and the same, no? Because pole voltage and phase voltage are same, and phase voltage, line voltage is derived and all of them. But it's not that straightforward. Pole voltage need not to be balanced. What we want? Phase voltage has to be balanced. You can ask me saying that, sir, how it will be possible without pole voltage balanced, phase voltage balanced? Is it right? Now what I will do is that I will give a 0 voltage to this. Here I will give some kind of Vx with an angle of alpha. This is Vy with an angle of y. Can I give that? They are not balanced. These are the pole voltages, they are not phase voltages. We have been always assuming that, what is that? This what I have written is a pole voltages. Phase voltage is what? The difference between these two is a phase voltage. Difference of these two is line voltages. Now I have given pole voltages very unequal, V 0 voltage, Vx with an angle of alpha, Vy with an angle of beta. Let me put alpha, not Vy with an angle of beta. I am not saying that the magnitudes are equal or angles are also equal. Will it work? So if you have been getting confused, just I will draw it as a vector. One phase has a 0 voltage, the other voltage with an angle of x, Vx, and the other angle is Vy. This is Vx with an angle of alpha, this is Vy with an angle of beta. Is it right? Now these two difference, this is going to be another voltage, no, this is triangle. This 0 to y, this will go for one phase and this is another phase, this is not another phase. Just say that this is 0 voltage, A, this is B, this is C. Is it right? A is 0, B voltage is Vy, this is Vx. Is it right? Now what is this voltage? Vac, this is Vab, this is Vbc. Can I not make these voltages equal by changing the magnitudes and angles? Of course, magnitude may not be possible, you are so kind to accept whatever I am saying it. These two magnitudes has to be equal and the angle can be changed such that this also can get equal. Once these three are equal, then line voltages are become equal. When line voltages are equal, phase voltage is automatically equal. Where the difference came between pole voltage versus phase voltages? If you remember, we removed the common mode voltage, 1/3 of Va plus Vb plus. Similarly, there is some offset will come out. What is that offset? This is your neutral point now. this is somewhere virtual neutral will sit here. Now from here what will happen? This becomes VA, this becomes VB, this becomes BC. That virtual neutral will be there. You can question me saying that where is the virtual neutral? All of them we do it in three-phase system. Where is the neutral? In the inverter, do you have any neutral? There is no neutral. This is a virtual neutral only. Capacitor, we have forgotten single phase time itself. Like first year they leave the education importance and all of them. No, is your students are studying for fourth year after placements? This is we are only teaching. No, in first phase we say that between the capacitors we require a neutral point to circulate the current. When we become three phase, you don't require neutral point, that will go on. They also may think that. Okay. So what I am trying to say that this virtual neutral automatically comes into happen, all the phase voltage will happen. You just see that difference between, if I could able to see that why should I believe pole voltage has to be balanced to bring the phase voltage balanced or to the line voltage balanced. I completely agree. Someone told phase voltage and line voltage has to balance. I agree, but pole voltage need not to be. You can tell me, sir, why this nonsense you are speaking? What is relevant here? The relevance is that if inverter leg got failed, what I can do is that I can have two capacitors here. That leg disconnect here and connect it here. That means you disconnect this leg, the A phase you shift it to here. Now A phase becomes what? 0 voltage. A phase 0 voltage, and B and C phase you can control any angle, any voltages. Can you not bring your balanced output voltage for a motor? Possible. That means what? An optimization is possible. This can be done in either fault condition or even non-fault condition also can be done. That means to generate my three-phase supplies, I don't require 6 switches all the time. I can have only 4 switches. But what is the additional thing which I have to pay? Capacitors. You can think of what kind of capacitors? Anything I'm like, you can interrupt me. Some of them already looking at very strange. Your students, don't throw anything on me, anything is fine. No, at least I'm here to make sure that your teachers are much better than me. Okay. So what you have to look at it, when I'm trying to tap here, what is the requirement of capacitor? Typically, these capacitors were designed to take only ripple currents. They are only designed to take the ripple currents in any system. But when you connect a phase there, what will happen? You are going to draw the phase current from the capacitors. This is a very serious problem in single phase also. That's what we call 2 times of the fundamental frequency capacitors will be carrying on, balancing and all of them. All those problems will come out. That means to say that, you know, the underline of the entire story which I have been telling, if you want to be ready for fault tolerance in a switch failure, I should have already capacitors installed in it, and I should have a mechanism to transfer that phase winding to between the capacitors. How effectively I can do it? On top of it, these capacitors should be ready to take my phase current. Now you can say here that, is these capacitors were required to have a rated to run for 100 years, or rated to run for 1 hour, or rated to run for 50 hours, or rated to run for 10 years? What you prefer? At least if it comes to me as engineer, I'll say that let work for 1 hour, that is sufficient for me. Why? Because I can reach nearest place, and then even if fallen it, then I can replace it something else. And when I am trying to design something here, I should not think for 10 years, which may not be used any time. And that 10 years, if I want to use that, the capacitor ratings has to be big, and I cannot overload it, I cannot do anything, and that is going to carry in the entire vehicle. Is it right? How do you optimize that? Will it doesn't require a lot of data to analyze? How do you reach that capacitance requirement? How do you assess what kind of environment? I assume that this is only sufficient to drive the capacitance. I assume that somebody is driving nearby Kulbarga, somebody is driving near Hyderabad, somebody is driving at Northeast, somebody is driving at Leh Ladakh. Will it not have a difference? In Leh Ladakh, the hilly terrains and all of them, you have to be very careful there with not only hilly area, you have to think about harsh environment conditions, the temperature differences, how your capacitors will react. In Hyderabad and Gulbarga, what will happen? The temperatures are not that greatly different. Like no, today we feel very cold if it comes to 10. I don't know what is the typical temperatures here. At least from my place, we used to call summer and hot summer only, not in Hyderabad. So what I am trying to say that there are a lot of things beyond you have chances to think of it. The environment conditions, terrain, and the fault, and the optimization of the things, and how do you handle it. I'll tell you, sir, is this a new problem? No, it's not a new problem. Just think about a missiles. Missile, you design a power converter. Is anybody will ask guarantee missile, no, the power converter which you are buying for a missile to ask for a 10 years of lifetime? No. What should you ask for a missile if you want to do it? Huh? Shelf time of 50 years. Shelf time, not operating time. Shelf time means what? It may be sitting there for 50 years, but once it launched, it has to work. And how much of time it has to work? Hardly 1 hour. Or kind of lesser than that. If it is more than that, then what will happen? Like no, our missile will be in someone's hand. So what I am trying to say that you should aware of that. There is something which is critical. It has to work whenever it is required. Something like in cricket, no, the 10th batsman will never come. Once he comes and play, no, it will be memory. Like I don't know how many you remember that Srinath played the 10th wicket winning against whom? I think some of you remember, no? Srinath and who is the other one? Raju. Anil Kumble. The last the last wicket, 10th wicket, I think 90 runs or say 90 plus runs. You correct me. That will be a memory kind of thing. That means it has to work. It doesn't require, like no, in the history of 100 years, not many people could have been worked, but once played, it is going to be memory. Similarly, like that. These capacitors may be there and may not be used, but when it is required, it has to work. So what kind of selection you will take, what kind of terrain, what kind of environment, what kind of, so this require a lot of data, lot of thing. Yeah, this is what I've been said. This is not my proposal. This is there in IEEE. There's a lot of literature is on that. Like, but I'm trying to say that I'm trying to bring in the design aspects of it to tell you. It is not like two capacitors placed. It will work. It will work in our labs. It will work in our labs. Even if it doesn't work, we'll make it work. We know how to adjust the voltage. We know how to oscilloscopes and all of them. That will work on it. Now, if this is the case, I'll say that multi-level inverters, if I go for a 2-level itself, it is like that's complicated. In 3-level, what will happen? The complication will increase or decrease? Increase, no. This is what a myth. If you go for multi-level, no. Multi-phase I have given, no? Multi-level inverters should be there. Hey, whatever. Multi-level, it's not coming. Break for tea, yeah? Okay. Sure. Then please go ahead. I missed this slide. you saved me at right time. Yeah.